Okay? So to get mgx and mgy, assuming you know mg, assuming you know the mass, you'll know mg, right? As long as you know what planet you're on and how far, and all that stuff, okay? Implicitly, if you're on the Earth, but if not, you know how to use Newton's law of universal gravitation to figure out g, okay? So anyhow, there's theta. That's the angle I want you to use, okay? Now in your dynamics class, if you're doing this, you probably have formulas. Well, you'd better reconcile them, okay? You know, and you might do it by triangles. I don't like that particularly because it's too easy to make an error in a plus or minus sign, which is why I kind of universally in physics say we use this angle so you never have to worry about the plus or minus. Okay? So, we have theta here, right? And of course, theta here is related to the angle of elevation of this ramp and the direction in which it's drawn, right? And you can easily figure that out. Like if theta's 30, or if angle of elevation is 30 degrees, what's theta?
2 tan.
No. That was a quick response, so I can kind of respect it. You're in the right quadrant. Where does the angle of elevation go in this picture?
Between the negative x-axis and mg?
No. No. If the angle of elevation is 3/10,000ths of a degree, then which axis is mg going to be close to? That is, you think of a horizontal coordinate system, a horizontal x-axis, and then you tilt it just
y-axis.
It's going to be the negative y-axis. Just do some 8th grade geometry. Okay? You can't make that mistake. Now, if you're on a test and you're thinking through, I'm just warning you, that's a common mistake. People add it to this because this is the x-axis and this is what you want to think of as the x-axis. It just doesn't hold, because mg isn't parallel to this thing that you're thinking of as the x-axis. So anyhow, there's mg. Here's theta. And if this is your angle of elevation, theta would be, in this case, 270 degrees minus alpha. Although that's not a formula you memorize, because if the angle, you know, if the thing is going this way with an angle of elevation alpha, then you're going to tilt the x and y axis this way, and mg is going to turn out to be in the 4th quadrant, right? So you just got to use really elementary common sense, but you got to use it rather than rely on something you've memorized, okay? You got to think a little bit, but it's very easy to draw this picture and get this angle right if you think, instead of use superstition or whatever. And that's equivalent to using memory of something you did before, okay? Okay, so there we have it. So now we can easily calculate mgy and mgx, okay? mgy is mg sine theta times j. And mgx is mg cosine theta times I. Okay? You don't have to worry about whether it's plus or minus. The sine and the cosine will give you the plus or the minus. Of course, then, once you get the results, you check them with common sense. Did I really get a vector in the negative j direction here, and in this case, in the negative I direction here? Okay? Well, if theta is between in the 3rd quadrant, both of these are going to be negative, aren't they? Now, again, if your picture's like this, and your mg vector turns out to be in the 4th quadrant, then this is still going to be negative, but this will be positive, right? Okay? That's the scheme that I want you to use in solving any problem involving say, a ball rolling down an incline. Okay? Make sense? Now, how do you work in things like other external forces or frictional forces?